Okay, so whenever you are asked to expand a plus b to the power of n, you can use binomial expansion formula or series to expand it, okay? So in the last class, we have discussed that the expansion looks like this. NC0, first term, that is a, over here, I'm calling this as a first term, this as the second term. First term to the power of n minus 0, second term to the power of 0, plus NC1, first term to the power of n minus 1, second term to the power of 1, plus NC2, first term to the power of n minus 2, second term to the power of 2. And this is going to keep on going on till you reach the last term, NCN, a to the power of n minus n, b to the power of n. We discussed that n has to be a positive integer value for this formula to work. N cannot be in decimal, neither it can be in fractions, neither it can be negative, okay? N has to be a positive integer for this formula to work. And for example, if you were asked to expand x plus 5 to the power of 5, the total number of terms are going to be one more than the power. So if the bracket has a power of 5, there are going to be 6 terms. Okay, 4, 5, and 6. There are going to be 6 terms. All right, this is what we did discuss in the last class. Now we are going to be doing an example. So in the first part, you are asked to expand 1 minus 2x to the power of 5. Okay, 1 minus 2x to the power of 5. So we are going to use binomial expansion to expand this. Can anyone tell me how many terms are going to be there in the expansion of 1 minus x to the power of 5? There are going to be 6 terms. Right. So 1 minus 2x to the power of 5, the expansion is going to be equal to 5c0. First term to the power, first term is 1 to the power of 5 minus 0, that is 5. Second term now is minus 2x to the power of 0 plus 5c1. 1 to the power of 5 minus 1 minus 2x to the power of 1 plus 5c2. 1 to the power of 5 minus 2, that is 3, minus 2x to the power of 2 plus 5c plus 5c3. 1 to the power of 5 minus 3, that is 2, second term to the power of 3 plus 5c4. 1 to the power of 1, second term, that is minus 2x to the power of 4, and the last is going to be 5c5, 1 to the power of 0, minus 2x to the power of 5. Now you can simplify this further. 5c0, you can use your calculator. 5c0 is 1. 1 to the power of anything is 1. Minus 2x to the power of 0 is also 1. So the first term turns out to be 1. Plus, okay. Now, 5c1, you can find this value from the calculator. You should now remember as well, 5c1 is 5 because nc1 is n. 1 to the power of 4 is 1. So 5c1 times 1 is going to be 5. 5 times minus 2 is minus 10x. And similarly, you can evaluate this. 5c2 is 10. 10 times 1 is 10 times minus 2 squared. So the negative number squared is going to give you a positive value times 4. That is 40x squared. Then you are going to observe that the next alternate terms are going to be negative. 5c3 into 2 minus 2 cube is going to be minus 80x cube. 5c4 is 5. 5c4 times negative 2 to the power of 4 is 80. 80x to the power of 4. 5c5 is 1. 1 to the power of 0 is 1. Minus 2 to the power of 5 is minus 32. Okay, so 32x to the power of 5. These are the expansion. So the first term was 1 and the second term had a term in x. So you guys can see over here that these are expanded in the ascending powers of x. The powers of over here, the power of x is 0, the power of x is 1, power of x is 2, and it keeps on increasing. The second thing to notice over here is that it was the difference of the two numbers that was raised to the power. So the difference of whenever you have expansions like these where you have a difference, you're going to always observe that the alternate terms are going to be negative. This is your observation. Okay, and in the last class we had a discussion on this, that both the powers of the first term and the second term must also add up to give you the total power. Okay, so 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, 0 plus 5 is 5, 5 plus 0 is 5. Okay, so this is the term independent of x. This is the coefficient of x, or the term in x, the coefficient is minus 10. The coefficient of x squared is 40. The coefficient of x cube is minus 80. Okay, so that's the expansion. Now part B says, and you're going to be getting these kinds of questions frequently. Part B says, find the coefficient of x cube in the expansion of 3 plus 5x times 1 minus 2x to the power of 5. Now they want the x cube expansion in the product of this. So when the results of 1 minus 2x to the power of 5 are going to be multiplied by 3 plus 5x, there are going to be the terms in x cube. They want that term. They want the coefficient of x cube. And so this is how you should do the working. You should go for a smarter way. Instead of multiplying. I'm sorry, is there any question?
So I was just saying, do you do 40x squared times 5x and 8 minus 80x squared x cubed times 3? Then you add the two values.
Yeah, exactly. So instead of, okay, let me write down all the terms first. 80x to the power of 4 minus 32x to the power of 5. Now these are all the terms in the expansion. I don't need all the terms, and I don't need to waste my time multiplying each and every term by 3 plus 5x. They just want me to give the coefficient of x cube. So I'm going to be looking for the term in x cube. So this 3 is only going to be multiplied by a term in x cube to get you the term in x cube. And this value 5x is going to be multiplied by a term in x squared to get you the term in x cube. So the only way you can get the term in x cube, the coefficient of x cube, is by multiplying 3 with minus 80. You can multiply 3 with minus 80x cube, and you can multiply by 5x with 40x squared. So 3 times minus 80x cube is minus 240x cube, and 5x times 40 is going to give you 200x cube. So the end result comes out to be minus 240 plus 200, that is negative 40x cube. So what's the coefficient of x cube in the expansion? The coefficient of x cube is minus 40. So you are going to write down minus 40 as the final answer. Okay, guys, let me know if the working is not clear.
Got it. Yeah.
Abdul Rahman, Manur, is the working clear?
Yes, sir.
So could you repeat B again?
B, okay. So for part B, I had to find the coefficient of x cube in the expansion of 3 plus 5x being multiplied by 1 minus 2x to the power 5. 1 minus 2x to the power 5 is this, right? The bracket that I have already expanded in the first part, whose result are these. So now I want to multiply this bracket with 3 plus 5x to get the term in x cube. So the process that I was trying to explain is that we don't need to multiply 3 with all the terms, because that's not going to be helpful. We just need to multiply 3 with the term in x cube to get the term in x cube. And we just need to multiply the term 5x with the term in x squared, because after multiplying, it's going to give you a term in x cube. So 3 times minus 80 plus 5x times 40x squared. These are the terms. When added, it comes out to be minus 40x cube. So the idea is that when we are going to multiply these two brackets, there is going to be a term in x cube whose coefficient is going to be negative 40. Are we clear with this?
Yeah, understood. Yes, sir. So,
Okay.
sir, in exam, I'll do like this.
Yeah, exactly. Okay. Now we are going to try the next one. Find in the ascending powers of x the first four terms in the expansion of. Okay, guys. Now in exams, you might be asked to expand the bracket till the first few terms. Okay, let's say similar to this question, they are asking to expand till the first four terms in the expansion of 1 plus x to the power 15. How, Abdurrahman, how many total terms are going to be there in this expansion?
16.
16. So the examiner doesn't expect you to expand till 16 terms, because that's his, like, this is only going to happen in the entire period of the paper. So you are all, so he is going to say that expand till the first four terms, or first five terms, or the first three terms. So 1 plus x to the power of 15. Now it has to be in ascending powers of x. So the first term is going to be 15c0, 1 to the power of 15 minus 0, x to the power of 0, plus 15c1, 1 to the power of 14, x to the power of 1. The third term is going to be 15c2, 1 to the power of 15 minus 2, and x to the power of 3, sorry, x to the power of 2, plus 15c3, 1 to the power of 12, x to the power of 3, and so on. We can just write dot 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 to represent that the expansion has not ended, but we were just asked to give the first four terms. So the first term is 1. Try to evaluate this. 15c1 is 15, so it's going to be 15x. 15c2 is 105, so 105x square, and 15c3 is 455, so that's going to be 455x cube. Okay, so you have expanded this till the first four terms. Okay, everyone try part B now.
Can you give us 1 minute more?
Okay, so that's the answer, you can check. Moving on. When 1 minus x upon 3 to the power of n is expanded in the ascending powers of x, the coefficient of x square is 4. Given that n is positive integer, find the value of n. What is the difference between this question and the question that we have done so far?
The before one asks us to find the coefficient of
They've
x.
given us the coefficient.
Yeah, and the value of n is unknown. Okay. Now, just to recall, what was NCR equal to? Remember the formula that we did in the last class? NCR
N over C over 0.
factorial, n factorial
n minus r
over
factorial.
n minus r factorial times r factorial. Good. So we are going to be needing help of this formula in this question. So let's understand the question. When 1 minus x upon 3 to the power of n is expanded in ascending powers of x, the coefficient of x square is 4. Okay. So if I were to expand 1 minus x upon 3 to the power of n, okay, the first term is going to be nc0, 1 to the power of n minus 0, second term to the power of 0, plus nc1, first term to the power of n minus 1, second term to the power of 1, plus nc2, first term to the power of n minus 2, second term to the power of 2. Okay. I don't need to expand further because the x squared term is going to be found from here. Do you guys agree? Because
Yeah.
over here, we are going to be getting a square. We are going to be getting a square on x. Now, let's take this for further calculation. NC2. Guys, what is 1 to the power of n minus 2? What is 1 to the power of anything?
Power of anything is 1.
1 to the power of anything is 1, right? And minus x upon 3 square, would you agree that it's going to be x square upon 9?
Yeah.
Okay. Can I write this term as NC2 multiplied by 1 upon 9 times x square? Can I write it like this?
Yes, you can.
Sir,
Okay.
could you explain why 1 and minus 2 is 1? Like, I
Because
don't get it.
1 to the power of 0 is 1. 1 to the power of 1 is 1. 1 to the power of 5 is 1. 1 to the power of any number
Oh, yeah,
is
yeah.
1.
Okay.
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 All right. Now, I was over here. I expressed 9c2 x square upon 9 as 9c2 times 1 upon 9 times x square. It's the same thing. The point I want to highlight over here is that the coefficient of x square is 9c2 times 1 upon 9. Guys, this is going to be a number, okay, which is going to be called the coefficient of x square. Now, is the coefficient of x square given in the question?
Yes, it's 4.
It's 4. Would you agree that these two values are equal?
Yeah, you would equate it to 4.
So I'm going to equate this. So I'm going to equate 9c2 multiplied by 1 upon 9 with 4. All right. Now the question is, how do I
So why
solve
did you
this without the calculator? This is where I'll be needing this formula. Okay. Can you guys try? NC2 is going to be equal to what? If I want to write down if I want to express this as a formula, 9c2 is going to be 9 factorial over
n minus 2 factorial times 2 factorial.
n factorial over n minus 2 factorial times 2 factorial. Abdul Rahman, do you agree with me till here?
Can you repeat from the start, like from NC multiplied by x square over 9? How did you get it from minus x over 3 square?
Okay, so 9c2 times x square minus x upon 3, the whole thing square, is minus x square is x square, 3 square is 9. I just simplified this. Okay, 1 to the
Yeah.
power of
So,
anything.
sir, why?
Yes.
Sir, why did you take why didn't you take NC0? Why did you take NC2?
Because I have been in the question, I have been given the coefficient of x square. So I'll just be needing the term in x square to solve this question. I don't need these terms. These are
Okay.
irrelevant for me right now. Okay. So
Okay.
I'll use this expansion. So as I was saying that 9c2 times 1 upon 9 will become the coefficient. Okay, that's the coefficient of x square, which is given in the question to be equal to 4. So you're going to equate the coefficient to 4.
Okay, yeah.
And now I need to use the formula for NC2. NC2 is n factorial divided by n minus 2 factorial times 2 factorial. Now there was 1 upon 9 over here. Can I multiply 9 with 4 and equate it to 36?
Yes.
Okay. All right. So after this, what is n factorial? If I ask you what is 5 factorial, what would you say? How can I evaluate 5 factorial?
Sir, saying
2 into 1.
5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, right? Similarly, 6 factorial is going to be 6 times 5 times 4 times 3 times 2 times 1, which I can clearly write as 6 times 5 factorial. Can I write it like this?
Yeah.
So what do you think n factorial is going to be?
2.
N multiplied by
N minus 1.
Multiplied by 2.
n minus 1 factorial.
multiply by
n minus 2.
n minus 2 multiplied by n minus 3, and it is going to keep on going on. But can I stop it by writing n minus 2 factorial?
Yes, you can cross out both the bottom.
So that I can cross out n minus 2 factorial from the denominator. Okay, 2 factorial is 1, 2. 2 factorial means 2. I can cross out n minus 2 factorial and n minus 2 factorial and equate the answer to 4 and solve it. Is everyone with me?
36.
Step?
So how did you get n minus 1?
36. Is it not 36?
Yeah, I'm sorry, it is 36. Yeah, Abdul Rahman, I'm just explaining. So, Abdul Rahman, please follow with me. If I have to write 4 factorial, would you agree 4 factorial is 4 times 3 times 2 times 1?
Yeah.
Okay, so if I have 5 factorial, can I write it as 5 multiplied by 4 factorial?
4. Yeah.
Can I write it as 5 times 4 factorial?
Yeah.
Okay, so if I have n, can I write it as n multiplied by n minus 1 times n minus 2 and so on? Can I stop it till n minus 2 factorial?
Yes.
So that is what I have done over here. I have stopped the expansion till n minus 2 factorial because I need to cross out n minus 2 factorial in the numerator and the denominator. So this simplifies my equation to n times n minus 1 divided by 2 equals to 36. Now this gives you a quadratic when you can times it by 2. 36 times 2 is 72. So n square minus n equals to 72. N square minus n minus 72 is equals to 0. You're getting a quadratic equation. So solve this quadratic equation. Get me the value of n.
8.
So what are the values of n coming out?
8 and minus 9.
Sir, it's negative 8 and 9.
Yeah, it's 9 and negative 8, isn't it? Okay. Which value makes sense? Are we going to accept both the answers?
No, sir, I will take the less one.
9.
Take 9,
You're going to
9, 9.
take 9. Why? Because it's a positive number. Remember, I told you that in binomial expansion, n must be a positive integer. Okay. So it's also mentioned in the question that n is a positive integer. So you have to discard this value. That's your answer. Okay. I want you guys to note down the working along with the question if you want. Let me know if the concepts are not clear right now. Manu, any questions here?
No, sir.
Abdul Rahman, do you have any questions or should I move on?
No, sir, no.
Okay. All right. Let's see question number
Sir,
5.
if the 36 was negative, the 36 was, if 72 was positive, could I say that I would choose the negative sign? I would choose negative 8.
No. N value cannot be negative in the question. The question says that n has to be positive. All right. Okay. Now let's do this question together. When 2 plus kx to the power of 8 is expanded, the coefficient of x to the power of 5 is 2 times the coefficient of x to the power of 4. Given that k is greater than 0, find the value of k. Now try to understand the question. If I'm going to expand this, it has power 8. Would you agree that the first term is going to be the term with x to the power of 0? The second term is going to be with the term with x to the power of 1. The second term is going to be x square. The third term, the fourth term is going to be x to the power of 3. The fifth term is going to be x to the power of 4. The sixth term is going to be x to the power of 5. How many terms are going to be there in total?
8. 9, 9.
9. Okay, you don't need to do all of
9.
this thing right now that I'm showing you on the screen. I'm just trying to explain it to you. I'm trying to giving you the concept. So the question says that when this is expanded, the coefficient of x to the power of 5, which is this guy, okay, this coefficient is 2 times the coefficient of x to the power of 4, which is this. Okay, so do I need do I need to expand till all the 9 terms? Or can I just go for the specific terms?
Go for
4 and 5.
specific terms.
Go for the specific term, right? Because it's going to be so much waste of time if I try to expand all the terms again and again. So I need to get to the specific term. So which terms do I need? Which 2 terms do I need for my question?
4 and 5.
6 terms.
X to the power of 4 term and x to the power of 5 term. Now, x to the power of 4 term, which term is it? Is it the first term, second term, third term, fourth term, or fifth term? X to the power of 4 term is the fifth term, right?
Yes.
And x to the power of 5 is the sixth term. Okay, now tell me this. For the first term, it's going to be NC0, right? For the second term, it is going to be NC1. For the third term, it's going to be NC2, NC3. So for the fourth term, it's going to be NC4. No. Yeah, NC4. And for the fifth term, it is going to be NC5. Is that correct?
Sir,
So
could
how
you
will it
repeat
be
from
x to the
start?
power 9?
Okay, one by
How will
one.
it be x to the
How did I?
How will it be x to the power 9? This is NC8, right?
Yeah, I'm
So,
sorry. That's not the option. Sorry.
how's it?
Okay. Now, is it fine?
Yes.
Okay. Yes, Abdul Rahman?
I was saying, could you repeat from the start from this NC?
Okay. So the idea was
NC3.
that in the expansion of 2 plus kx to the power of 8, there are going to be 9 terms. And if I arrange the 9 terms in the ascending powers of x, the first term is going to be x to the power of 0, followed by x to the power of 1, followed by x to the power of 2, up till x to the power of 8. But the question is not asking me for the expansion of all the terms. It is just talking about 2 terms. It is comparing 2 terms, that is x to the power of 5 and x to the power of 4. Okay. So I just, in the entire expansion, I'll be just working out the 2 terms. And that particular 2 terms are the terms with x to the power of 4 and the term with x to the power of 5. In order to get the term with x to the power of 4, I'll be doing NC4. And for the fifth term, I'll be doing, for x to the power of 5 term, I'll be doing NC5. So the whole idea was that if I want the term in x to the power of 4 and I want the term in x to the power of 5. Okay. So I'm looking for the specific term. Instead of the entire expansion, I'm looking for the specific term. So to find the specific term, you can use this formula, NCR. Okay. The specific term, TR plus 1, is going to be equal to NCR A to the power of N minus R B to the power of R. It's the same formula, guys, but I'm talking about a specific term over here. N is the total power of the bracket, which is 8, and R is the value of the term. For example,
Sir, what C?
because C is the same C that you have been using up till now. NCR.
No, I mean, what is there a name for C or something, or it's only C, letter C?
It's only letter C. It's a combination. It's called the combination. Okay, now let me explain this. So I just want the term in x to the power 4. So the term in x to the power 4 is basically the fifth term, right? And that is going to be when r is 4. Okay, you want x to the power 4. So because you have a linear expression inside, the term in x to the power 4 is going to be occurring at the 5th position. So you just need to calculate T5. It's going to be 8C4. First term, R value is going to be 4. Okay, first term is 2. So 8 minus 4, 4. And the second term is Kx, that is to the power of 4. This is going to give you the term with x to the power of 4. So if you simplify this, 8C4 comes out to be 70. 70 times 2 to the power of 4 is 1120. Now k to the power of 4 is k to the power of 4 and x to the power of 4. So this is my term. This is the coefficient of x to the power of 4. Similarly, I'll find the coefficient of x to the power of 5. The x to the power of 5 term was occurring at the 6th position. So our value is going to be 5. 5 plus 1, that is 6, T6. So 8C6, first term to the power of 8 minus 6, that is 2. Second term, that is 6. 8C6 is 28. 28 times 4 is 112. K to the power of 6, x to the power of 6. So, have I done something wrong? Oh yeah. Guys, my bad, sorry. I'm just solving it again. I had to find the term in x to the power of 5, not x to the power of 6. I made a small error over here. Please do the working with me again. So for T5, it's going to be NCR. So it's going to be one less. 8C5, first term to the power of 8 minus 5, that is 3. And second term, that is kx to the power of 3. So 8C5 is 56. 56 times 2 cube is 448. K cube, x cube. So x cube coefficient comes out to be 448 times k cube. Okay, so now I have the coefficient of x to the power of 4. And
wouldn't it be x?
Yeah,
Wouldn't
my
this be
bad.
5?
Sorry. Yeah, you are right. This is going to be x to the power of 5. This was 5. So k to the power of 5, x to the power of 5. Guys, this is the coefficient of x to the power of 5. Okay, now I have the coefficient of x to the power of 5 and I have the coefficient of x to the power of 4. The question says that the coefficient of x to the power of 5 is 2 times the coefficient of x to the power of 4. Okay, so the coefficient of x to the power of 5, that is 448 k to the power of 5, is 2 times the coefficient of x to the power of 4, that is 1120 k to the power of 4. So I just need to solve this equation for the value of k. You can strike out this. You can k to the power of 5 divided by k to the power of 4 is equals to 2 times 1120 divided by 448. I hope you guys understand the working that I'm doing right now. K to the power of 5 divided by k to the power of 4 is k to the power of 1. And this thing results in 5. So k value is 5.